So what is a Latin square? Latin square was created from a paper written by Leonard Euler, who used Latin character to represent the square that he designed. A Latin square is an array that has dimension n times n with n different symbols, character, or numbers, each occurring exactly once in a row or column. If you do Sudoku, it's a very similar concept, but instead of using numbers to put into each square, we use characters, A, B, C, and D, and so on. The standard Latin square design consists of letters written in alphabetical order in the first row and column. However, that's not the only way that you can represent those combination of letters. There are 12 different ways that you can represent a 3x3 Latin squares, and the numbers of different Latin square increase rapidly with the numbers of levels. Meaning for every permutation of rows of a given Latin square, use a new Latin square, and similarly for column permutations. It is recommended that the square used in the actual experiment be chosen at random from the set of all possible squares of the desired dimension. Application for Latin square design. Latin square are used for design experiments. Latin square designs allow for two blocking factors. In other words, they are used to control two sources of Newton variability at the same time. Whenever there is more than one blocking factor, a Latin square design will allow you to remove the variation from these two sources from the error variation. It should be noted that a Latin square is an incomplete design, meaning it doesn't include observation for all possible combinations of variables. This happened because you only get to pick one square out of all of the possible squares in the design, making it an incomplete design. An example of Latin square design being used is scheduling different workers on different days to test the efficiency of each worker on different machines. The column in this case will be the different machines and the row will be the days of the week. So in this case, the three factors that are being tested are the workers, the days of the week, and the machines, which is represented by the letters. An assumption that we make when using a Latin square design is that the three factors, the treatments and the two Newton factors, do not interact. If this assumption is violated, the Latin square design error term will be inflated. Some other properties. Because of the way that it is designed, the columns and rows need to equal each other. It is also possible to represent the Latin square in different ways, for example, as a long list as shown. The randomization procedure for assigning treatments that you'd like to use when applying Latin squares might be a bit restricted because of the structure of the square. The ideal way to randomize would be to select a square from the set of all possible squares. However, a more practical randomization scheme is shown. 1. Randomly permute the columns. 2. Randomly permute the rows, and then assign the treatment to the Latin letters in a random fashion.